A study was done on proctored and non-proctored tests. The results are shown in the table. Assume that the two samples are independent simple random samples selected from a normally distributed populations and do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 0.05 significance level for both parts. Okay, so the proctored mean, we're given the proctored mean versus non-proctored mean. So we have, for the proctored, we have an N of 30, and a sample mean of 75.86, and a sample standard deviation of 11.13. Non-proctored, we have an N of 35, sample mean of 86.92, and a sample standard deviation of 19.19. Okay, so let's test the claim that students taking the non-proctored test get a higher mean score than those taking the proctored test. Let's state the null and alternative hypotheses. So for these, I'll be honest, if I'm doing these, I'm going to write this down before I select, just so I don't get sucked into one of their distractors. So here we're trying to test the claim that the non-proctored is a higher mean score. So mean 2 is greater than mean 1. So mean 2 greater than mean 1. Okay, here's one right here, or mean 1 is less than mean 2, another way to say that, right? So mean 1 less than mean 2, that looks like A or D. But we know that the null is always equals, so it has to be D. Okay, the test statistic T is, now recall, we're only using technology to compute these. If you use the view example, you're going to see a series of steps to go through this with hand calculations. So I'm going to use StatCrunch, and then afterwards I'll use the TI-83. So question help, and go to StatCrunch. Okay, so I'm going to go to, I have two independent means. So I'm going to go to stat, tstat. I have two samples, I think you can see that, with summary. This is summary data here. If I were given the raw data, I go to data. Okay, and now let's type in mean 1. So the sample mean 1 is 75.86. Sample standard deviation of mean 1 is 11.13. And the sample size is 30. Do the same thing for sample 2. Okay, so there's sample for mean 2. Notice it automatically pulls the variances. You'll get slightly different results if we do this. So we generally stay out of the pool. And because it also says assume the population standard deviations. It says do not assume the population standard deviations are equal. Again, in StatCrunch, we've seen this before, they will generally set these to 0. So we're doing a hypothesis test, mu1 minus mu2 equals 0, which is the same as mu1 equals mu2. And then we're doing h1 minus h2 is less than 0. All I'm doing is subtracting mu2, sorry, I may have said h, mu2 from both sides. We don't really need summary stats, we already have the summary stats, so let's go ahead and press compute. Okay, so there is our t-stat, negative 2.89, and there's our p-value, which I'm sure it'll ask for in a moment. Yep, and now the p-value, and just pay attention to rounding, so the round to 3 places is needed. So let's look over here. We have 0.0027, so 0.00, whoop, you can't see that. 0.0027, so 0.003. Okay, now we should be getting used to the conclusions for the test and the decision that we make with regard to the p-value and the significance level. So we have a very low p-value, 0.003, which is certainly lower than our significance level. Remember, this is our threshold. If it doesn't state 1, we usually assume 0.05. It does state 1. 0.05 is significance level. And so we are going to reject HO. And if you kind of look at it, it looks like you're going to reject HO, right? It looks like the non-proctored test. I mean, if I'm given a test, if I'm giving a sample size and I give a class with non-proctored and a class with proctored, I'm going to go, whoa, that probably didn't happen by chance, right? So I'm going to reject the fact that we said they were equal, right? That's the null, that we think there's no difference. So I'm going to reject HO. There is enough evidence. So reject HO. There is enough evidence to support the claim that students taking non-proctored tests get a higher mean score than those taking proctored tests. So early on you may have been memorizing if the P is low, reject HO. Hopefully it's kind of starting to make sense now, and if not, that's okay. Hopefully by the end it'll start to sort of gel a little bit. We reject the HO. There is enough evidence. The likelihood of us getting a difference this large, the difference here is around 11 or so, 11 or 11.06 if my math's correct. So the difference that large happening by chance, given that the null is true, is 3 out of every 1,000 samples would I see something like that if this is still true. So I'm going to say, that's probably not true, so I'm going to reject the fact that they're equal and go with the fact that mu2 is greater than mu1, or mu1 is less than mu2, however you want to think about it. Construct a confidence interval for testing the claim. Students taking the non-proctor test get a higher mean score than those taking the proctor test. So let's go ahead and set around to 3 places. Let's keep that in mind. So some software programs will automatically run a confidence interval when they do a hypothesis test. StatCrunch does not do that, but it's easy enough. We can, once we run this, we can go ahead and go into Options, Edit. So when I go into Edit this, and I choose confidence interval, because it's a one-sided confidence interval, alpha with 0.05, I'm only looking at, I need to double that alpha. So the confidence level, instead of being 95, is going to be 90. So we're going to do a 90% confidence level and press compute. So I get a lower limit of negative 17.462, an upper limit of negative 4.658. So does the confidence interval support the conclusion of the test? And it does, right? Because we said that it would be, we would reject HO, and it does support, because the confidence interval does not contain 0, or because the confidence interval contains probably like only negative value. So another way to say that is it doesn't contain 0. We go from negative value to negative value, it's not going to contain 0. Similarly, if I had both positive values. So often I don't like the negative value, so I'll switch the order and make this, I'll flip that around just to make it, I can make it make more sense in my head, but this is the way they've set it up, so that is fine for this particular example. Okay, so I hope that helps. I'm going to show you now on the TI-83 or 84. So we'll just do the same problem. I'm going to press Stat, scroll over to Test, and this is a 2-sample t-test. So number 4. Okay, we're given the summary statistics, so have it on Stats, and then enter in your X bar, 75.86, and standard deviation 11.13, and then the N of 30. Do the same thing for the second non-proctored sample. And our hypothesis is that mu1 is less than mu2. We generally do not pool, and we're just going to calculate. And we get the same t-statistic I received earlier and the same p-value. Now let's run back and do a confidence interval. So press Stat, Test, and this is a 2-sample t interval. No, don't select Z, it'll get really close to it, particularly samples this large. But make sure you pick the T, and again, because we have a 0.05 significance level, rather than 95 confidence level, we're going to do 90. Now, if this were a 2-sided test where the alternative hypothesis was not equal to, then it would be a 95%. And notice we get exactly the same thing we obtained earlier, negative 17.46. Oh, one of the problems here, right, is that they only round to 2 places rather than 3. There is a way to get those individual ones, and I'll show you that. So if you need to go out more decimal places, the calculator here only gives us 2 for some reason for this first one. It gives us 3 for the second one. I'm not sure why it did that. So what we're going to do, if you ever need to just peel off one of these variables here, first let me check my mode. Okay, it's floated out, so I'm not sure what's going on. I'm going to press vars, and we're looking at a statistics variable, so number 5. and we're looking at a test that we just ran. So we see all the variables here we can peel off. So I'm going to scroll over here to test, and the variable that I want is upper and lower. So there's lower and there's upper. So lower is the one that I need, right? That's the one that would not come out. So just press enter, and there's the full variable, negative 17.462. It gave us the upper one far enough. If we need to go back to get that, press vars, go to number 5, go over to test, and we go over up to upper. And there's the upper one floated out as far as it can go. So I hope that helps.